have two tests. One is the Z. Okay, Z is starting with x bar mu over sigma over square root n. Okay, and another test is T with x bar mu s over square root n. So there is a difference of sigma. So here is the difference. One is the population standard deviation, okay, STD, and S is the sample STD. Okay, so these two tests depending upon if the population standard deviation or the sample standard deviation is given. So both tests are similar tests. So in each of the tests, you will form the null and alternative. So there. So in both of the cases, the hypothesis could be in null we could have three hypotheses where mu is equal to mu naught, mu could be less than equal to mu naught, and mu could be greater than equal to mu naught. Okay, so these three type of hypothesis could be there, which is null, and corresponding alternative will be for equal to it is not equal to, for less than equal to it should be greater than mu naught, and for greater than it should be less than mu naught. So correspondingly we have the alternative hypothesis as well. Okay, in both of the T or Z cases, this hypothesis will remain the same. Now we will talk about the rule. Rule for rejection of H naught. Okay, rule for rejection of H naught. So this is the rule for the rejection of H naught, and it will be different for each. And now rule for the rejection of H naught. So if it is relating with H naught where mu not equal to mu naught, okay, so reject H naught if Z greater than Z alpha by 2 or Z less than equal to minus Z alpha by 2. So the two kind of situation will be there. And for the T, if HA mu not equal to mu naught for the T test, then T greater than T alpha by 2 and T less than equal to minus T alpha by 2. So this is the reject of H naught. Okay, so this is the rule for rejecting of H naught when mu not equal to mu not equal to mu naught when alternative. Okay, should we move on? If your alternative is mu less than mu naught. Okay, in this both of the cases, z less than minus z alpha, so reject h naught and then reject h naught for the t is t less than minus t alpha. Okay, and if HA is mu greater than mu naught, then reject H naught. If Z greater than equal to Z alpha, or for T greater than T alpha. Okay, so that is the rule. So along with T alpha, we have to consider the degrees of freedom as well, n. Okay, because each alpha is associated with degrees of freedom n minus 1. Okay, in T table. So that is the rule, and now we'll go for the question. Suppose that it is known from the experience that the standard deviation of the weight of 8 ounces packages of cookies made by a certain bakery is 0.16. So the standard deviation, so we have been given a standard deviation of this. Okay, to check whether its production is under control on a given day, that is to check whether the true average weight of the package is 8 ounces, employees select a random sample of 25 packages and find that their mean is here. Since the bakery stands to lose money when mu is greater than 8 and lose the customer out when the mu is less than 8, test the null hypothesis mu is equal to 8 against the alternative. So both of the hypotheses have been mentioned here already. Okay, so simply we'll go to the, we would write the null and alternative, the first step. So mu is equal to 8 and mu should not be equal to 8. So that is to be tested. Okay, so the standard deviation is 0.16. Okay, (0.16) is the standard deviation. N is equal to 25. It is also mentioned. So now we will put the values, and x bar is also given. I think x bar is also 8.091. 091. Okay, so now we'll put the values inside the formula, which is x bar mean over sigma over square root n. So x bar is 8.019 minus 8 divided by 0.16 square root of 25. So what z value should be there? So it is 2.84. Okay, now we have to calculate the Z alpha. So alpha considered to be 5%. Okay, if we are considering alpha 5%, so it means that what is needed? So because it's a two-tail test, so it should be, so Z 0.025. Okay. Alpha, how much is it? 0.01. Okay, so we could have alpha is 0.01. Okay, and alpha by 2 is 0.005. No, this one. Okay, so it means you have to calculate Z alpha by 2. What is this number? So Z alpha is 2.575. Okay, so this is your Z alpha by 2. So your test says that because the positive value of Z, so it must be Z greater than Z alpha by 2 to reject H0. Okay, if then reject H0. So Z is 2.84 greater than 2.575. It is true, so it means we reject H0. Okay, reject H0 mean we found evidence in favor of alternative hypothesis, which means that process is out of control, which means that process is out of control. So there is considerable actions to be taken to control the process, because if underweight or overweight is going on, so they might be saying that your cost will be increasing, or you might lose your customer because of the underweight. So those are two possibilities.